Hello everyone, today I'd like to introduce what is RSA crypto system. Here is how it works. So we suppose that Alice wants to send a message to Bob. So Bob has to tell Alice how to encrypt her message. So here is the step. So the step 1, the Bob need to pick two primes number P and Q. So usually these two primes are large. And so here, for example, we can pick 3, Q is 11. And the second step is we calculate N, that's P times Q, and calculate its phi N, P minus 1, Q minus 1. And this is called Euler-Trojan function. So here we have N is equal to 33 and phi N is equal to 20. So the third step, we have to pick a number E in 1, 2, 3 to phi N, and such that the GCD E and finance is 1. So for example, we can pick E equal to 13. So the last step is that we calculate Z, which is the inverse of E when we mod phi N, and such D exists because the GCD of E and phi N is 1. So here we find that AD is 17. So you can calculate that as 13 times 17 congruous to 1 modulo 20. Okay, so now Bob sent the pair N E to Alice. This is, we call it public key. In our example, this is 3313. And Bob himself kept the private key, and it is ND. So we can erase this stop. Yeah, in our example, that ND is 3317. Okay, so now they can send, Alice can send her message to Bob. So how she do? So, for example, she wanted to send a message X, and she calculate X to the part of E modulo and let's see what happened. And then she sent this Y to Bob. Okay. So in our example, x, for example, is equal to 2, and we can calculate 2 to the power of 13, which is modulo 33, and this is equal to 2 to the power 5 squared times 2 to the power 3. So it is 8 and minus 1 squared. So the answer is 8. So here y is 8. So you just send this to Bob. Okay. And then Bob has to use his private key to decrypt the message. So how can he do? He will just calculate. It's 8. He can use his private key and just calculate y to the power of d and modulo n, and this will give him the original message x. So we can calculate this, for example, that here of 8, 17. So this is 2 to the power of 51, so modulo 33, and we just see that this can be written into 2 to 5 and 10 times 2, and we know that it is minus 1 when you modulo 33, so the answer is 2. So we actually get back the original message.